All right, looking at the inverse functions homework, just a reminder that when you are looking at functions being inverses of each other, you want to do the composition of those two functions in both directions, and if they both equal x, then we know that they are inverses. So if we want to determine it about these two, again, we want to do the composition both ways, so g of f of x, and then we'll find f of g of x. Okay, so first one, g of f of x, we're going to take f of x and plug it into g. So that's looking at f of x, and it's going to go in place of the x's into the g function. So that will look like 4 over x minus 1 plus 4 all over 4 over x minus 1. Now, we've done this before, but if you want to just kind of clear out those fractions, because that looks pretty crazy there, we could just multiply by x minus 1 on the top and the bottom of these two big fractions here. And what that does, when it distributes to these two, it'll cancel out the denominator. And so this is going to equal just a 4, because that would cancel. And then we're going to have to multiply this 4 by x minus 1. But that's the new numerator. Looks a lot nicer. And then when this x minus 1 in the bottom here multiplies times this fraction, it again will cancel out. So all that's left is 4. So I'm going to distribute on the top. We're going to get 4 plus 4x minus 4. And this is all over 4. You can see the 4 and the minus 4 cancel. We're left with 4x over 4, but then the 4 over 4 also cancels. So we're left with x. So that shows in one direction anyway that it looks like they're going to be inverses. So let's try the other way. So now we're going to plug g into f. So g into the f function. So this will be 4 over x plus 4 over x minus 1. Again, we can clear those fractions like we've been kind of seeing, multiplying by x on the top and x on the bottom. So x on the top will be equal to 4x, because there's no fractions going on up there. On the bottom, the 4 or the x will distribute to that first piece and the second piece. The first piece, the x cancels, so we'll just have x plus 4, and then the x times negative 1 makes negative x. So what I have here, these x's will cancel, so we just have 4x over 4, but then those 4's will cancel, leaving us just with x. So it does check. They are both inverses of each other. All right, for number 2, it wants us to find the inverse of this function. So sometimes it's nice when we can kind of talk about what happens to our input and then undo those operations, but it's not as clear, especially when we have an x in two different places here. So what we're going to do is just interchange our x and our y, since that's the meaning of this inverse thing. And so our outputs right here, that's our f of x, is going to be x equals y minus 4 over y plus 2. Since I have that fraction, I'm going to multiply by y plus 2, just so I don't have to see that anymore. And I actually have y in two places. So the next step right now is to kind of try and get y's alone, but really we need to get our y's all on one side. So I'm going to start by distributing the x so I can see all of my y terms. So I have a yx and a y. Those are my two y terms. I want those to be on one side and then all the other stuff to be on the other side. So I'm going to move my y over here, So I'm going to have yx minus y. I still have my 2x and I still have my negative 4 because those cancel. I'm going to move my 2x over, So that's yx minus y equals negative 4 minus 2x. So once all my y's are on one side, what we're going to have to do, and this is like a little bit of a trick in a way, if we only want to see one y but you see 2, let's factor it out. So that way we'll only see one y. So if I pull y out, I'm going to be left with x minus 1. And so now if I want my y to get alone, I'm going to divide both sides by that x minus 1. And you can see that I now have y alone. We could write that a little bit nicer if you want to. F inverse of x, using that notation, is going to be negative 4 minus 2x over x minus 1. So you see a lot of negativity in there, but it's not totally clear that it's the inverse of that function up there. But again, if you want, you could check it by doing those compositions. All right, for number 3, it wants us to find the inverse of this g function. So this one actually is really nice. Even though there's a lot of operations going on to our input, there's only one input. And if I think about G, I'm going to write it in words. When I input something, it first subtracts the A, then it cubes, then it divides by B, then it subtracts C. So if I'm looking at the inverse of G, I want G inverse, it's going to go the other way. So this is kind of like a forward direction, and G is going to come the other way, undoing all those operations as it goes. So to undo those, it's going to, instead of subtract C, it's going to add C back in. Then instead of dividing by B, it will multiply by B. Then instead of cubing, it's going to cube root. And then instead of subtracting A, it's going to add A. So in math notation, we're going to say the inverse of G inverse of X, is equal to, again, let's see what happens to our input starting from that back end there. We're going to take our input, we're going to add C, multiply that whole thing by B, take a cube root, and then we're going to add A. So again, that's in word form. If you want to, you can interchange our X and our Y, our input and output, and you'll get the same exact thing, because really you're just like undoing all the operations that you would do to solve for a variable in an equation. All right, for number 4, it wants us to find F inverse and then graph both those functions. So again, there's like the 2 ways to think about what's going on with F. If we think about it with like words, we could say that our input is being multiplied by 2 and then minus or subtract 3. So then that would mean that the inverse, again going the opposite direction, is going to have to add 3, then divide by 2. Okay, if we write that down, the inverse would look like inverse of x plus 3 over 2. Now that is a linear function because the degree is 1 there. If I want to write it in slope-intercept form, since it's a line, I would take the x over 2, which is really 1 over 2x, plus 3 over 2. So that would be my inverse function, again, found by kind of doing the words. Or if you want to do it more algebraically, what that means is we're going to interchange our x and our y here. So then that's going to be x is equal to 2y minus 3. And when we solve for y, again, that's that like undoing or unwrapping. We're going to add the 3. So we get x plus 3 equals 2y. Divide by 2. And we have the same thing, you can see. And again, we'd write it as 1/2 x plus 3 over 2 is equal to our inverse. So next we're going to sketch these guys. So the original function, again, it's in slope-intercept form. The y-intercept is -3, so I'm going to sketch that on my graph. The slope is 2, so I'm going to go up 2 over 1. Up 2 over 1, up 2 over 1, and connect the dots here. And so this is my function, f of x. Now the inverse has a y-intercept of 3 over 2, which is 1.5, so I'm going to put that right in the middle. And then it's going to go up 1 over 2. So remember, it's up 1 whole space. So up 1 whole space over 2, I'm kind of in this middle ground. And we're going to go like that. All right, and so that's f inverse of x. I could have also just identified these points and then interchanged x and y if you didn't like graphing those fractions. That's what we had done in class. And you can see, though, that they are a reflection over the identity, which is y equals x. So we can determine that our inverse function is correct by looking at the graphs because they reflect over y equals x. So yay, we did it good. All right, flipping over to number 6. It wants us to look at f of x equals x squared minus 3. And again, it has that restriction. Now that's, again, because x squared minus 3 is a parabola that's been shifted down 3, and it's not 1-to-1. And what we want to talk about is 1-to-1 functions. So we know this because it passes the horizontal line test if we only look at the right side. So what I mean is x squared minus 3 is down 3, and normally it would be looking like that. But as soon as it says x is greater than or equal to 0, it only wants the part where we're greater than or equal to 0, which is that section. So I'm going to cut off this side, and so now we are 1 to 1. So it wants us to find f inverse. And again, we can do this algebraically or just kind of thinking about it. It's kind of nice on this one. If we do it, we can look at it both ways if you want also, but if you do it algebraically, we're going to say, okay, well, x is equal to y squared minus 3. But again, we're keeping in mind here that we only are looking at that side where x is greater than 0. So we add 3, you get x plus 3 is equal to y squared. We square root, and again, we're only going to look at the positive root, square root of x plus 3. And that's because we know that x is greater than or equal to 0, and if we're looking at that negative root, we wouldn't have that reflection that we want. So we know that if 0, negative 3 is on the original graph, negative 3, 0 is on this one, and you can see that that matches up right here, and that's f inverse of x. So this is f inverse, and this is our function f, and so you can see it's doing that crossing over that y equals x. It's that reflection. So now if we think about the domain of f, because we're restricted, it's only from 0 to infinity. And then the range of that function f was shifted down to negative 3 to infinity. Now the domain of f inverse, that one goes all the way to negative 3 now. And the range is 0 to infinity. And so the thing that we're going to notice is that when you're talking about functions, just because x and y switch, that the domain and range of f and f inverse are kind of flip-flopped. So if I know the domain of f, I know the range of f inverse. And if I know the domain of f inverse, I know the range of f. So the domain of f becomes the range of f inverse, and the range of f becomes the domain of f inverse. All right, and again, we needed to restrict the domain of f in order to find the inverse function, because that was the only way to make it 1 to 1. And in order, if it's 1 to 1, then it would pass that horizontal line test and basically be a function, which is what it asks for, in the other direction.